Hello, Edward again, and now I'm going to do an example of another line integral, but this time, rather than f being a typical function, it is actually a vector field. So we're taking a line integral of a vector field along a curve, which thankfully is already parametrized for us. Now, we're not going to worry if f is conserved or not, we're just going to dive straight into it using the method. Using this parametrization. So first I'm just going to write f out in a different way. I'm just going to write it out in these brackets. So the x component is x and y, x times y, and the y component, as you can see there's a j here, is 3y squared. And now I'm going to write the vector field in the same way too. This is just, you don't have to do it this way, it's just for visibility, and because we're going to take the derivative of this, so it's more readable this way than the I and J format. So here we have our curve. Now this integral here is equal to, so if you look at t, which is, it goes from 0 to 1, like that's our curve. We start r of 0, and we follow this curve all the way to r of 1. Those are going to be our bounds. We're going to integrate with respect to t. So from 0 to 1. Now we want to take our function, but we want to plug in x of t and y of t. So you want to replace these as functions of t because of our given parametrization. So in this case that is x of t and that is y of t. And we want to take the dot product of this with r prime of t. Note that this is not r of t, it's the derivative of this dt. So naturally we should calculate this. So if you look at r of t right here, we can figure out what the derivative of this is. So what's the derivative of 11t to the fourth? Well, we'll bring the 4 out, that's 44t cubed. And now for the y component, that's just 3t squared. Okay, that's good. Now we have to plug in x of t and y of t into the original function. So now our f is, okay, so it's x times y for the x component, right? So what is x? X is this, 11t to the 4. And what is y? That's t cubed, so you multiply those two together, that's our x component. Our y component is 3y squared, so write the 3. And I'm going to square whatever y is, so because 3y squared, and y is 3 cubed, t cubed, sorry. And now we take this and we dot this with r prime of t. Dot. Okay, so that's gonna be that's gonna be our integrand, which is this. So let's write that out. So 11t to the 4 times t to the cubed dot 3t to the 6 dot, sorry, I noticed that my r prime of t was not in visibility, so now you can see it. So how do we take a dot product again? We multiply these two terms and we add it to these two terms. So 11, so 4 plus 3 is 7. We multiply this by the first term here, which is 44t cubed. Now I'm not going to actually multiply these two together. You'll see shortly why. And 3t to the 6 times 3t squared, that's 9t to the 6 plus 2, which is 8 dt. And once we calculate this, we're effectively done. Now if you notice here, 7 plus 3 is 10, so then we have like t to the 10 which when you integrate it is t to the 11 over 11. When you plug in 1, what do you know? This 11, that 11 will cancel out. Same thing for this. How convenient. 9 to the 8 is but the derivative of t to the 9. That's the antiderivative of 9 to the 8. So this is going to work out to be 44 plus 1, which when you add them is 45. That is the answer to this question given this f and this curve.